In this video, I'm going to be doing a few problems on scatter plots and regression lines. So I'll quickly review those two first, as always, and then we'll go through the problems, okay? So a scatter plot, what that is you're just plotting your data points on a graph. So you're going to do your experiment, you got your samples, you have some XY points, essentially. That's part of your data. You just plot them on your graph. So that's what all these dots are, for example. Those are your sample points that you collected. All right, so that's all a scatter plot is. A regression line, or sometimes it's known as line of best fit. So on the SAT, you're only really dealing with linear regression. So the line of best fit is just a linear line that can kind of model your sample data. All right, so you can see in this example, your black dots, once again, are your actual collected points. You want to represent it as a linear line. It's just easier, and I'll give you an example in just a little bit. So this is the line of best fit. You're trying the best of your ability to model your data with a linear line. So why would you want to do that? So you can see, for example, there's no data point at x is 13. Okay, so instead of you having to go and get the sample measurements or the sample points, you can just use this line of best fit to kind of estimate what the y value is for x13. Okay, so if your data kind of generally represents this linear line, then at x is 13, you can use that line to kind of approximate what the y value is. Okay, so this would be about the y value. It might be up here, it might be down here, but it's a relatively good approximation. That's one of the uses for this line of best fit, or this regression line. Okay, so with that said, let's do these few problems. Questions 1 and 2 refer to this. The scatter plot above shows the average scores of 10 golfers and their weekly practice times. The line of best fit is also shown. What is the average score of the golfer that is farthest from the line of best fit? Okay, so go ahead and try that first on your own. Okay, so which point is farthest from the line of best fit? It looks like it's this point. It's the furthest away. Okay, so it's asking what is the average score. So we go look at the y value. So what is that? This looks like it's tick marks of 2. So 2, 4, 6, 8, right? So it looks like it is 98. So the answer is C. Okay, so this is just using the line of best fit. Okay. Next, there are 2 golfers whose average practice time is the same. What is the difference between their average scores? Okay, so it's hard to show both, so I'll just solve it right now. So you can, of course, go ahead and pause the video, but the 2 golfers whose average practice time is the same. So average practice time is the x-axis. This is the only one that has 2 points for the same x. So both of them had 9 hours on average practice time in a week. Okay, so what does the question ask? What is the difference between their average scores? Well, for this one, it's 100. This one, it's 90. So that difference is 10. Okay. What is the median score of the 10 golfers? Okay, so I guess this is still referring to this one, so this should be 2, 3. What's the median score to 10 golfers? So go ahead and try to answer this one. Okay, so the median is the middle one. Okay, so we are going to cross that one on each side, one at a time, okay? So this is the highest score, cross that out. This is the lowest, and then we alternate. This is the next highest, this is the next lowest. This one is the next highest, you gotta be careful. This one's the next lowest, then this one, then this one. So the median will be the average of these two. So what is that? That's 96 and 98, the average is 97. Okay. And then the last one is pretty quick video. Shift this up a little more. According to the line of best fit in the scatter plot above, which of the following best approximates the year in which the number of cars repaired by Jay's Motor was estimated to be 4,500. Let's go ahead and try this one. Okay, so this is one of the applications of using the line of best fits. Similar to what I was giving in that other example, we didn't have the x value. We can approximate the y value for the x value. This is the inverse. If we want to know the x value for a given y value, we can also do that. Okay, so this is asking what year was the number of cars repaired. Estimate number of cars repaired is 4,500. Let's go to 4,500. That's right here. Okay, so we go down the x. What year is that? That's about 1996. So that's your answer. Okay, so this is just using the line of best fit to make an approximation for a point that you don't have, exactly as I was saying earlier. Okay, so these are usually pretty easy. And hopefully this video was helpful to explain the concept one more time if you didn't get it before. All right, as always, please like and subscribe if this video has helped you. And the next video, we're going to be talking about, we're going to be looking at how to interpret these tables of data, okay? So please look out for that video.